Hello everyone. So I'll again go through the files PPTs and solve some problems if I can. I have not like so much idea and about operations. I'll just go through the PPTs and try to find something important if there is. Introduction to operations. So I think yeah, these are just description of what operation and supply chain is. Supply chain is moving information, material, or you know any resource from manufacturing to service or vice versa. And operations is manufacturing and service process used to transform the resource or any product from a farm to the product desired by the customers. Then these things I think we can give it a read. Efficiency, effectiveness, and value. There are three efficiencies: producing goods or providing service at the lowest cost. Effectiveness is doing the right things to create most value for the firm, and value is attractiveness of a product given its feature and durability. Okay, and this there's some descriptions. Okay, there is nothing much about it. Theory of constraints. Okay, this one also you can give it a read. There is nothing much. I'm just going to solve the problems, mathematical problems. If there is anything, I'll try to. So flow unit is the unit which flows through the whole process. Arrow means the flow of flow units and triangles are inventories. Okay, so yeah, this problem in yeah, I'm here. This takes 2 days, this takes 6 days, and this takes 5 to 6 hours. And raw material 2 came to this three on the 0th day, the first flow unit. So after that, these are the inventories, and here for the first one, it will be present here after 2 days. It will be present after 6 days, and it will be present after 5 to 6 hours, like 0.5 days. Okay, so after this, they will wait here because for welding, all the three are needed. So after 6 days, all three will be ready and will go to this welding part. So it will be starting at sixth day and ending at seventh day because it takes one day. And from that, it will again take 5 to 6 hours. So start with 7 days, end at 7.5 day, and this will start at 7.5 day and end in 8.5 day. So after 8 point, and then after that, this will work like that. So at 8.5 day, first flow unit completes. And for the second flow unit, so for the first, it was starting from 000, but for the second, we can control it, right? So we know that of that among these three, the bending takes the most time. So, and we have to wait for the bending to complete. So there is no point for others to, bulk up and create inventory here. So what we will do is calculate how after how many days again bending will be present here. So first was present after 6 days. So the second flow unit will be present here after 12 days, right? If we are starting after in the sixth day, because this is the bottleneck, it takes the maximum time. So if in the second unit, it will start from the sixth day only, and it will complete here on the 12th day. So we have to plan accordingly that the cutting also gets presented here at the 12th day only. So for that, this should start at the 10th day. So yeah, like for the second flow unit, it should start at the 10th day. Similarly, this also here should be present at the 12th day. So we should start producing it at the 12 minus zero point 0.5, so 11.5 day. So that at the 12th day, all three are present and no inventory is needed. After that 12th day, it will start from here, 12th day, end at 13th day. Then 13th day, it will start here, and 13.5 it will end, and then 13.5 here, and 14.5 it will automatically end. So this is, I don't know if there will be exams on this, but maybe calculating when to start according to bottleneck can come. Then, yeah, so this was the ice cream case study. I don't think there was mathematics there. Machine capacity. Capacity implies an attainable rate of output. And there is this thing, sorry, one second. So there are some description about machine capacity concepts, process capacity concepts. I'm not going through this. I'll maybe go through it later. Then cycle time capacity is 1 by cycle time. So cycle time means that how much time one process unit flow takes time, an average time between completion of two successive unit. So is this another example like task A, task B, task C, and task D? Task A starts from 0 to 5th. At the fifth point, task B will start and complete at ninth. But for the next process, it will wait for the P2 to complete at the task A, so it will start from 10. And at the 10th, it will again start and end at 14 and wait for the A to complete and 15th, like this. So this 1 minute, this 2 minute, these are called uh, idle time. So because of the previous process, task A is the bottleneck, the first task, we are seeing idle time only. So if there were some bottleneck in between, we also would have seen blockage or block. So if the cycle time is 2 minutes per unit, then capacity is at per hour we will do 30. So these are, if this increases, this decreases. So if per unit takes 4 minutes, in an hour we will do 15. Yeah, so bottleneck blocked, yeah. So station with the lowest capacity is the bottleneck generally. Yeah, so station with the lowest capacity is called bottleneck. So there that can result in two situation. One is blocked and one is stopped. So if the bottleneck is at the very beginning, then it will create some, idle time for the next tasks. And if the bottleneck is in between, the before the process before that will stock up, and after a certain point it will get blocked because there would be too much inventory before the bottleneck to complete. So that is called blocked. Efficiency, labor utilization, there again some theoretical things. Takt time is the target time per unit as derived from customer demand. Takt time means amount of time available by units demanded per unit time. So it's basically amount of time available by the units demanded per unit time. So if cycle time is greater than takt time, all demands cannot be met. So takt time means the time which is demanded by the demand, and cycle time is how much we can serve. So cycle time is kind of like a supply, and takt time is kind of like demand from the economics term one. So if demand is higher than supply, sorry, I said the opposite thing. Cycle time is the demand, how much we can meet, and takt time is the demand, how much we are getting. So if cycle time is greater than takt time, then all demand cannot be met because we need more time to complete than the demanded time. Okay. Then there's the Little's law gives the rate of which materials move through a process. Average queue length equals to average waiting time into arrival rate. Not much in this too. Yeah, so this one, how it looks like starved and blocked. Like you can check through this link. This is now starved because the bottleneck is in between. So it will be starved some at some point, but now there will be a block this one because the bottleneck is in between. Waiting lines. So theory. In waiting lines, this is something good. Rho is utilization, which is equals to lambda by mu for single server, and C is the number of servers. And it is less than one. It should be, I guess. If Q arises when the short-term demand exceeds the capacity. So lambda is the arrival rate, and mu is the kind of service rate. So if lambda is greater than mu, then lambda by mu will be greater than 1, which would result in Q because it cannot be greater than 1. That is our capacity, right? So if it is short term, then it will be a Q, and if it is long term, then Q will explode to like infinity. Then theory, interval rate is just basically difference between the last two, 10 minus 0, 12 minus 10, like that. And this generally is a exponential. If you plot this, it would be looking like a exponential distribution. And common distributions are Markovian, exponential, deterministic, and general distribution. So it will be given how what kind of distribution it is. If it is MM1, that means it's Poisson and exponential. If some deterministic service time is given with Poisson arrival lambda and one server, then MD1, then other are there. And I guess formulas are also given somewhere. Yeah, lambda is arrival rate, mu is service rate, and rho is server utilization, lambda by C mu. This is number of servers. Most of the cases, C is one only for our simplicity. And these are the formulas which we have to remember, I guess, because sir won't provide these things. Expected number of customers in the system, okay, is so let's say it's a car wash facility and some cars are being washed and some cars are in the queue. So expected number of customers in the system, like so it will be how many are in queue plus how many are in service. So LQ gives the number of uh, customers in the queue, and this lambda by mu is the utilization factor or for a single server and for how many cars are being washed or how many customers are being served actually. The addition is total number of customers in the system. In that LQ is the number of the queue and it's denoted by this, and it will come later in, I think there is something related to this in the later classes. WS is the expected waiting time of a job in the system. So WS is if let's say for the car is coming into the system, how much time it is waiting in the line, and then how much time it takes to process it. The total is expected waiting time for the car in the system. So it will be the time it take waits for the queue in the queue, and then the time it takes in the while it was getting washed or something. So I forgot how these things came up, but just in the last point, if you can see, ALQ is the expected number of customers and lambda is arrival rate. So if we divide it, it will give you the expected waiting time of a job in the queue. Okay. So with that, we are adding service rate because, sorry, 1 by service rate, because if the service rate is 10 per hour, then 1 by 10 will give you 6 minutes, which is time taken for each car. So waiting time in the queue plus the time it takes to wash the car gives you the total time the car is in the system. Then this Little's law, again, I don't know, LS equals to, this is the formula, LS equals to, WS equals to basically, okay, from here that came, WS, LS equals to lambda into WS. So if you multiply lambda into this, you will get LS. Then this, there was some explanation that from zero, lambda is the rate how people like customers come into the system, and mu is the rate from how it goes back. So the rate balance equation is lambda into P0 equals to mu into P1. From that, we can calculate P1 equals to rho P0. And from 1, we can have lambda to go to P2, and again mu2 go to 0, and also from P2 you also can go back to 1. There was this kind of explanation from that this equation came where lambda plus mu into P1 equals to lambda P0 plus mu P2. Okay, so oh yeah, I guess if you look into this state 1, from here we can have lambda to go to mu2 and mu to go to 0. So this is why this part came, and how the arrows can come here from 0 P0 with lambda, and from P2 mu. So this is the right hand part. From that P2 we can calculate rho square into P0. So this is how, if we have I states, this will be the formulas and the total of it will be 1. And from that we can calculate P0 as 1 minus rho, and Pn equals to 1 minus rho into P to the power n. Okay, so P0 is basically the state where there is empty, like there we can have utilization there. Then the formulas, this will be given in the exam MM1 and MD1. The only difference is it's by 2, and WQ is also given. PN is also given. P0. The lambda by mu is basically rho. Yeah, this thing. Now there is this example where it is given that, so that I just read through the question once. So I can see that this is given. Change the color once. This is given. So arrival rate, right? Because arrive at a rate. So lambda equals to 15 per hour. And service rate is 1 every 3 minutes. Mu. So 1 every 3 minutes. And it has given that assume Poisson arrival and exponential service times. So it is an MM1 because it is given that Poisson arrival and exponential service. Now there are some, I think, yeah. So if we go to the solution, it is given that it's MM1, how we came to that conclusion, and then calculated the lambda is 15 per hour, and mu is 1 every 3 minutes. So it is, we have to get it into the same units in hour. So 1 every 3 minutes means 20 per hour. So that is mu. After that, we can calculate the utilization factor rho by taking the 15 by mu. So generally lambda should be less than mu, and it happens like that because if rho is greater than 1, then there should be an infinite queue. So from that, we have different interpretation, like if rho is 0.75, probability of server is idle is 0.25, 1 minus this, and server is busy is 0.75. Probability of arriving customers has to wait. So 0.75 because server is busy at 0.75 the probability. So that time is the customers who will come will wait. Then probability of arriving customer directly entering the service is 1 minus this same, and probability of arriving customers does not wait in the queue is 0.25 again. Average number of busy servers are C into P. Now here C is 1, so rho is 0.75, so the answer is 0.75. Average number of customers being served is again 0.75. Average number of customers in queue is given by this formula for MM1, lambda square by mu into mu minus lambda. And if we substitute the values, it will be 2.25 customers. And average number of customers in system is customers in line plus customers being served, which is 0.75 lambda by mu. So using the formula, we can have that three customers will always like average three customers will be in the system. 2.25 customers will be waiting and 0.75 customers will be being served. It's an average. Now, average waiting time in queue is given by this formula LQ by lambda. Now, lambda we know 15 and LQ we calculated to be 2.25. 2.25 by 15 equals to 0.15 hours. So that is the time, a average waiting time in queue. And average waiting time in system is this 0.15 plus how much time it takes to complete the task. So 0.15 plus 1 by mu. So you know, so 1 by mu means 1 by 20. So it will be zero point 0.2 hours. So it will take zero point 0.2 hours to average to complete the service. 0.15 in waiting line and zero point 0.5 in 0.05 in the actual service. Now, because of the limited space availability, so I would like to ensure with 95% confidence. Manager would like to ensure with 95% confidence that no more than three cars will be in the system at any time. What is the present level of service for three car limit? So, and what level of Taylor use must attend, and what must be the service rate that Taylor ensures 95% service level. So, you have to calculate the service level currently at three cars. So, we want that it should be three cars, right? Not more than three cars, the states. So, currently we can have three cars maximum. So, how many states we can have? At a state where there will be zero car, a state where there will be one car, a state there where will be two cars, and at a state where there will be three car. So the in the solution, if you see, the service level is calculated as the probability of all four service level is calculated as the probability of being in the all four state P0, P1, P2, or P3. So if we calculate it with the formulas we have discussed just right now and do the sum, we will come to this form answer. So current service level is, we know the value of rho currently, right, which is 0.75. So substituting that value here, we have current service level as 0.683. But our target is to be 0.95. To have that 0.95, this value should be 0.95. So here 0.95 equals to this. Now we cannot change the arrival rate of customers. Customers will come in their rate, right, when they are free. So that is 15. What we can do is calculate the new mu service level, like how fast we can do our service. We can increase that. So from this, we have to substitute the formulas and calculate the value of mu. And mu comes to be around 31.72 per hour. So we had previously mu as around 20 per hour, I guess. Yeah. If you see 1 every 3 minutes means mu is 20 per hour. So for increasing the service level, we have to make mu as 31.72 hour. Mu equals to 31.72 hours. So per hour. So we have to be so fast that we should cater to 31.72 cars per hour, which is currently around 20 per hour. So by doing that, we can increase the service level. And for that, we also have to increase our uh, we have to increase our service rate, and which will result in utilization factor to go down because it was previously 0.75 and it decreased to 0.47 because now we have capacity of doing 31.72 per hour and average is 15 how much customers comes. So utilization of the machines will be decreasing. That is the reason. Now, yeah, this formula I think all of us submitted here. They have said that. Okay, I'll just read it once by just pausing it. Yeah, so I just gave it a read that for a car wash alone charges 0.50 and past shows is this. The average profit on gasoline fill up is about 0.70 and the cost of car wash to robot is 0.10. So only car wash profit is zero point 0.5 is the charge and cost is zero point 0.1. So profit is 0.4 and gasoline profit is $0.7 dollars. So this is given and also given robot stays open. So working time for the robot is 14 hours. Now robot has three power units and drive assemblies and the franchise must select the unit preferred. Unit 1 can wash car on every 5 minutes and leased at $12. Unit 2 is at every 4 minutes and unit 3 in 3 minutes, right? So now three new service, these are the service rates, like in which how fast we can provide service and their associated cost. So what we have to calculate is that, okay, now complete the question. The franchise estimate that customer will not wait in line more than 5 minutes. Waiting in line cannot be more than 5 minutes. And a longer time will cause robot to lose the gasoline sales as well as the car wash sales. If the estimate of customer arrival rate using in-cash invoices in washes is 10 per hour. So 10 per hour is the arrival rate. So we know lambda equals to 10 per hour. Three service rates are given mu1, mu2, and mu3. So we can calculate lambda by mu1, lambda by mu2, lambda by mu3 to calculate the server utilization in each case, right? So all three we can calculate. Now what we will have to do is I'm just thinking where should I solve the problem? I guess. Okay, so I just moved the problem here. So what are the things given? Lambda equals to 10 per hour, mu1, comma mu2, comma mu3, and how much is the profit for car wash, which is $0.4 car wash, and gasoline is to $0.7, $0.4. Sorry for the handwritings. So, and 14 hours it works per day, and the cost associated with the three is $12, $16, and $22. So what we have to calculate is, it is given that customers won't wait more than 5 minutes. So we have to take calculate how much time it takes, like would take if we are taking server 1, server 2, and server 3. So for that, if we go back to the formulas here, yeah. So here the customers won't wait in line. So the formula is for that WQ equals to LQ by lambda. That is the waiting time. That should not be greater than 5. And for calculating LQ, this is the formula given. So first we have to calculate LQ by mu. LQ equals to lambda square mu, that thing. So I'm just writing down the formulas. LQ equals to lambda square by mu into mu minus lambda. By the way, this is a MM1 because we have, uh, you know, sorry, give me one moment. Sorry, this is a MM2, right? Because, yeah, so how to understand if it is an MM1 or MM2? So there, here the 10 per hour is given as, uh, you know, it's the rate of arrival, and the service rate, mu1, mu2, and mu3. It is not given that it is exponential. It is given as how many they will do. For mu1, it is every 5 minutes. For mu2, it's every 4 minutes. For mu3, it's every 3 minutes. And so these are called deterministic. So in the problem only, they have determined the mu1, mu2, and mu3. So that's why it is a MD1. So yeah, that's the thing. So for that, we have to use this formula and this. So using that, if it was given that it was exponential, we would have taken MM1 formula, and but not. So LQ equals to lambda square by 2 into mu minus lambda. This was the formula, right? Yeah, and WQ equals to LQ by lambda, and WQ equals to LQ by lambda. So if you calculate this, for the first one, I'm showing just mu1, which is LQ1. If you are calculating LQ1, it will come around 2.08 customers. So average customers in the waiting line is 2.08. And how much time they will take wait in the line is WQ, which is LQ by lambda equals to 2.08 by 10, which is whatever the answer will be, it will be in hour, right? Because uh, the formula is given 10 per hour, this lambda value. So, and mu also we are finding it, calculating it in per hour rate. We have to convert mu everything in per hour rate. So, for the first one, 5 minutes means per hour 12. So, this is the mu one. So, using that, WQ will be around, I guess, 0.208 hour, and multiply it by 60, we'll get 12.48 minute. And same LQ2 will be something. WQ1 is this. WQ2 will be 4 minutes. So we can see that average WQ2 is less than 5. We have to have this less than 5 to not miss out any revenue. So WQ2 is good. But just that is not enough to say that, yeah, we'll take WQ2 and not take WQ1, like the server one. Why? Because maybe the associated cost, so here we have to calculate the marginal cost and marginal benefit. So by just upgrading from server 1 to server 2, there will be some excess revenue and profit, but maybe the cost to get that will be much higher. So for that, we have to calculate how much revenue we are losing, or sorry, how much profit we are losing, and how much cost we are saving by taking the first server. So for that, what we have to do is we have to calculate the arrival rate at 5 minutes. So every if uh, it is done by every 5 minutes, how many customers will come into the the company. So for that, what we have to do is it is given that the sorry, WQ should be 5 or less, right? So we are calculating what should be the WQ. So for the first one, if the waiting time is 5, what should be the arrival rate? So with the survey waiting time with 5, it is given that they won't wait more than 5. What will be the new arrival rate? So then 10 people won't come to the center, right? Then less people will come and lose revenue. So how many people will come into the company for their car wash or whatever? We have to calculate. So for that, WQ should be max to max 5. So WQ formula is LQ by lambda, right? So LQ is formula is this, and if you are dividing it by lambda, the lambda square will omit, and the new formula will be lambda by 2 into mu minus lambda, and this should be 5. Now I'll just create a new, sorry, or can I write here? Oopsie. Oh, I can write here. Okay, I can remove it. So by now we have to find, if we are taking the first server, how many people will come? Because 10 people won't come, because according to the calculation, 10 people will come only if the waiting time is less than 5 minutes. So substituting the WQ equals to 5 minutes for the first server, where the formula is lambda by 2 into mu minus lambda equals to 5 minutes. We have to convert it again in hour because the calculations are in hour. So 0.083 it will come in hour, divided by 60. So here we have we have mu, because in the first we are calculating for the first server. So first server's mu is fixed, that it can only do on every 5 minutes it can do one car wash. So substituting the mu values as the mu, which is 12 per hour, we will get lambda by 2 into 12 into 12 minus lambda equals to 0.083. Now if we calculate, wait, yeah, so now substituting the values, we can get lambda equals to 8. So with the server one, only 8 customers will come in per hour and 2 will go back in average. These are all average, by the way. So if Lambda is 8 with the new server, first server. So we will lose 2 customer per hour, right? And the machine works for 14 hours is given. So in a day, we will lose 28 customers. And given that half of them comes for the only car wash and half of them comes for the gasoline fill up. So 14 customer with gasoline fill up will lose and 14 customer with car wash will lose. In gasoline, the profit is $0.7 per customer, and for car wash, it's zero point 0.4 per customer. So if we're now calculating it and adding it up, so 14 into zero point 0.7 is, and 14 into zero point 0.4 and some, you can do it in calculator, it will come around $15.4. So we will lose $15.4 of profit every day if we are not taking the second uh, one, right? And how much we are saving if we are taking the first one? The first one is 12 per day, cost is 12 per day, and second one is 16 per day. So we were saving $4 by not taking the second one, but we are losing $15.4. So there should be, this is not beneficial for us, so we should go to the second one where we won't lose any customers and we won't lose this $15.4. Okay, waiting lines, theory, 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 theory. So forecasting and everything I'll do later.